Welcome to episode 53 of your CYSA Plus Prepcast. In today's session, we are diving into one of the most impactful ways to enhance cybersecurity operations, integrating application programming interfaces, also known as APIs and plugins. These tools serve as the connective tissue that links various platforms, automates routine tasks, and accelerates response actions across the cybersecurity ecosystem. Whether you are managing security alerts, aggregating threat intelligence, or enforcing configuration baselines, APIs and plugins enable you to do it all more efficiently. For analysts preparing for the CYSA Plus certification, understanding how to use and integrate these technologies is not only part of the exam objectives, but is essential to performing real-world cybersecurity work at a professional level. Let's begin with a clear definition of APIs. An API, or Application Programming Interface, is a structured set of functions that allows two software applications to communicate with each other. In cybersecurity, this means that different security tools, like a security information and event management platform and a threat intelligence database, can exchange information seamlessly and programmatically. APIs act as bridges between systems, enabling data exchange, control commands, and coordinated workflows without needing direct human interaction. For analysts, APIs are foundational to building efficient, automated, and integrated environments. Plugins, on the other hand, are modular software components that extend the functionality of an existing application or platform. They act as small add-ons that can be installed to add specific capabilities without modifying the core software. In cybersecurity, plugins are frequently used to incorporate new detection mechanisms, integrate with additional tools, or customize dashboards. For example, an analyst might install a plugin into a SIEM system that allows it to parse logs from a new cloud service. This modular approach gives analysts flexibility and adaptability when new requirements arise or when threats evolve. One of the primary uses of APIs in cybersecurity is enabling tools to share and enrich security data automatically. When platforms such as SIEM systems, endpoint detection and response solutions, and cloud-based firewalls are connected using APIs, they can push and pull data from one another in real time. This exchange enhances detection accuracy, correlates incidents across environments, and accelerates analyst investigations. Instead of manually copying data between platforms, APIs allow this to happen instantaneously and with greater precision, leading to faster detection and more coordinated responses. Analysts also use APIs extensively for automation. Tasks like pulling new threat intelligence from a database, initiating a vulnerability scan, or pushing indicators of compromise into an alerting system can be done automatically using API calls. These tasks can be embedded into larger automation workflows that are triggered by certain events, such as the appearance of a suspicious login or the identification of a malicious process. This kind of API-driven automation significantly reduces the amount of manual effort required for day-to-day operations and enables analysts to focus on more strategic activities. Plugins expand the functionality of core platforms by allowing analysts to customize or enhance their tools without needing to build entirely new systems. For instance, in a vulnerability scanner, a plugin might add support for a new operating system. In an EDR platform, a plugin could introduce new behavioral rules for detecting advanced malware. Plugins can also help analysts quickly adopt new techniques, support custom reporting formats, or introduce automation capabilities without requiring deep software development skills. This ability to scale functionality modularly is crucial for agile and adaptive security teams. Many vendors offer public APIs to facilitate easy integration with third-party tools. Analysts routinely use these APIs to connect threat intelligence feeds, automate remediation actions, or ingest data into centralized monitoring systems. For example, an API provided by a threat intelligence vendor might be used to pull new indicators of compromise into a SIEM tool every few minutes. Similarly, a cloud service might offer an API to allow automatic enforcement of access control rules or configuration settings. Vendor APIs are essential for building comprehensive and cohesive security architectures. Using APIs and plugins effectively requires more than just access to the tools. It requires careful planning and standardization. Analysts need to work with clearly documented APIs that define what data is exchanged, how authentication is handled, and what formats are used. Standard data formats like JavaScript object notation or JSON and extensible markup language or XML are often employed to ensure compatibility between systems. Documenting integration workflows, expected behaviors, and error handling routines is critical to ensuring operational reliability and minimizing integration failures. Analysts often write their own scripts or small applications to take full advantage of API capabilities. These custom scripts might query threat intelligence databases for additional context, extract incident data for reporting, or automate triage tasks for high-volume alert queues. Languages like Python, PowerShell, or Bash are commonly used for these purposes. Scripting gives analysts fine-grained control over automation logic and allows for the creation of specialized tools that exactly match the organization's unique security requirements. These custom integrations are often lightweight, highly effective, and reusable across different projects. One of the most powerful uses of API integration is automated data enrichment. When an alert is generated by a SIEM or EDR platform, API calls can be used to automatically fetch additional details about the alert artifacts. For instance, an alert that includes an IP address can be enriched using an API call to a reputation service, adding information such as geolocation, threat score, or historical activity. File hashes can be checked against malware databases to identify known malicious payloads. This contextual data enables faster triage and helps analysts determine severity and urgency more accurately. As with any automation, ensuring security and reliability is paramount when integrating APIs and plugins. Analysts must build strong error handling into their workflows to account for failed connections, unexpected responses, or incomplete data transfers. Monitoring the health and performance of API integrations is also important. A broken API link might silently cause automation to fail, leaving threats undetected. Analysts regularly test integrations, confirm authentication processes are working, and review logs to ensure data flows as expected. Validation and oversight are critical to preserving the integrity of automated systems. For more cyber-related content and books, please check out cyberauthor.me. Also, there are more security courses on cybersecurity and more at baremetalcyber.com. Integrating APIs and plugins provides immediate and measurable benefits when applied in practical cybersecurity workflows. One of the most valuable use cases is rapid incident response orchestration. When analysts integrate APIs into response workflows, they can automatically execute actions like quarantining infected endpoints, disabling compromised user accounts, or blocking malicious IP addresses without manual intervention. For example, a SOAR platform might receive an alert from a SIEM, automatically enrich it with threat intelligence, confirm the presence of a known threat, and trigger an API-based response that isolates the affected host from the network. This level of orchestration enables near-instant response and minimizes the window of exposure. Vulnerability management also benefits substantially from API integration. Analysts can leverage the APIs offered by vulnerability scanners to automate every step of the process, from scan initiation to data retrieval and remediation tracking. An API-based integration might allow for nightly scans across designated network segments, followed by automated tagging of high-risk vulnerabilities. Those vulnerabilities can then be pushed into a ticketing system with appropriate severity classifications and remediation recommendations. This integration reduces the manual overhead associated with vulnerability lifecycle management and helps organizations stay ahead of evolving threats. Identity and access management is another operational area improved through API integration. Analysts can use identity platform APIs to automate user provisioning when a new employee joins the organization, adjusting group memberships and enforcing security policies automatically. Similarly, when an employee departs, the API can trigger automatic account deactivation across all connected systems. These workflows not only increase efficiency but also eliminate common security gaps caused by delayed or inconsistent account management. In addition, access logs can be queried via API to conduct regular auditing and compliance checks. Security orchestration platforms such as SOAR rely heavily on APIs and plugins to centralize control of the entire incident lifecycle. These platforms act as a coordination hub for the various security tools an organization uses. Each tool connects to the SOAR platform through its respective API, enabling automated actions, data exchange, and unified visibility. Analysts can build playbooks that tie together inputs from firewalls, endpoint detection systems, SIEM platforms, and more. Instead of switching between consoles, analysts manage and control security workflows from a single location, drastically improving response speed and reducing complexity. Cloud environments especially benefit from API-driven security integration. Public cloud providers such as Amazon Web Services, Microsoft Azure, and Google Cloud Platform offer comprehensive APIs for monitoring infrastructure, managing identities, deploying services, and enforcing policies. Analysts use these APIs to automate detection of misconfigurations, monitor access logs, enforce encryption standards, and initiate corrective actions in real time. This level of automation is critical in cloud environments where systems are often ephemeral, highly scalable, and rapidly changing. API integration ensures that security controls keep pace with dynamic cloud operations. Security data analysis and visualization also improved through API use. APIs allow raw data from logs, sensors, and monitoring tools to be pulled directly into analytics platforms like Splunk, Elasticsearch, or Tableau. Analysts can then generate dashboards, track trends, and visualize threat patterns without manual data exports or reformatting. Real-time API connections ensure that these dashboards are always up to date, supporting better decision-making and situational awareness. The ability to centralize and correlate data from multiple sources also helps analysts identify cross-center threats and uncover larger attack campaigns. One of the key advantages of integrating APIs and plugins is the increased flexibility they provide. Security teams often face evolving challenges, new regulations, and emerging technologies. APIs and plugins allow analysts to quickly adapt to these changes without overhauling core systems. Whether it's integrating a new thread feed, automating a new response step, or adding support for a new SaaS platform, APIs and plugins provide the adaptability needed to remain effective and responsive in a fast-changing landscape. This flexibility extends the lifespan and value of existing tools and maximizes return on investment. Regular evaluation and refinement of API-based workflows help ensure that integrations remain aligned with security goals and operational needs. Analysts track performance metrics, gather user feedback, and monitor integration behavior to identify areas for improvement. For example, if an automated threat enrichment API consistently returns outdated data, analysts may switch providers or adjust their queries. Similarly, if a plugin introduces delays or errors in alert processing, it can be updated or replaced. These continual improvements ensure that API-driven workflows remain efficient, reliable, and relevant. Proper documentation is essential to maintaining transparency and consistency in API and plugin integrations. Analysts create detailed records that explain how integrations are configured, what data is being exchanged, which systems are affected, and how automation scripts operate. This documentation supports knowledge transfer, compliance audits, troubleshooting, and operational reviews. Without clear documentation, integrations can become opaque and difficult to manage, especially during personnel changes or system upgrades. Well-documented integrations also reduce the risk of introducing errors during maintenance or expansion activities. To maintain a high level of proficiency with APIs and plugins, continuous training is necessary. Analysts stay up to date with changes in API endpoints, vendor documentation, and security platform capabilities. They learn scripting techniques, study integration case studies, and participate in hands-on labs to strengthen their practical skills. Training also helps analysts develop a deeper understanding of security automation frameworks and architectural design principles. By investing in professional development, organizations ensure that their teams can fully leverage the power of integration and automation in their cybersecurity operations. To summarize episode 53, Integrating APIs and plugins into cybersecurity workflows provides a wide range of benefits, from streamlined incident response to enhanced automation and operational flexibility. These tools allow analysts to eliminate manual bottlenecks, improve data quality, and execute faster, more consistent responses to threats. Mastering the use of APIs and plugins is not only critical for your CySA Plus exam preparation, but is also foundational for performing at a high level in modern cybersecurity roles. These integrations support scalable, agile, and effective security operations that evolve with the threat landscape. Stay tuned as we continue your detailed journey towards CySA Plus certification success. Thanks for listening. To learn more about cybersecurity, please visit baremetalcyber.com. There you will find best-selling books, videos, and even more free cybersecurity training courses. Please subscribe to the Prepcast and our various podcasts. And thanks for listening.